let's compare additive and multiplicative relationships. We're going to start with additive. Now, this is a pretty straightforward idea, but an additive relationship is a relationship between two quantities that involves addition. Now, we have a standard equation for both additive and multiplicative, and I'm going to write those down because they're very important. So my standard equation is y equals x plus a. Now, my y and my x are always going to stay y and x, but my a is going to fluctuate depending on what the problem is. If it's a problem about the number 2, then a is going to be 2. It's going to be y equals x plus 2. If it's about negative 37, then I'm going to say y equals x plus negative 37. Let's look at a situation. This is kind of hard to read, so I'll read it out loud. It says, Jolene is packing her lunch for school. Her empty lunchbox weighs 5 ounces. That's important. I'm going to highlight that. What is the relationship between the weight of the items in Jolene's lunchbox and the total weight of the packed lunchbox? So this right here is a keyword in itself. The word total means that I need to add my lunchbox plus whatever I plan on putting in my lunchbox. So let's look at the situation in a table. So my x is going to be on top always, my y is going to be on the bottom, and my x is going to represent the weight of my items. So if you can't see that, it says weight of my items, and this one says total weight. So if I add in one item, my lunchbox now weighs a total of 6 pounds, 6 ounces. If I add in 2 items, my lunchbox is now going to weigh a total of 7 ounces. To get my lunchbox to weigh 8 ounces, I need to add 3 items. If I add 4 items, it's going to come 9 ounces. And then 5 ounces is 10 total. So let's turn these into ordered pairs. Now, ordered pairs we gather from our table. And our table looks a little bit different than I've seen in the past, than we've seen practiced and whatnot. Our ordered pairs are going to be on top of each other instead of next to each other. So let's put these down here. So my first ordered pair is 1, 6. Then I have 2, 7. I have 3, 8. 4, 9. And 5, 10. There's always one kind of bonus ordered pair that I always like to talk about, and I like to talk about the situation of 0. So if I add 0 things to my lunchbox, how much will it weigh? Well, we know the empty lunchbox weighs 5 ounces, so there's an ordered pair for you right there. Now let's take a look at how we're going to make our equation. So we have our standard equation all the way up here, y equals x plus a. So I'm going to put y equals x plus, then I'm going to leave this second part blank because I don't know what we're adding. I know that the a is going to fluctuate, so I need to put something there, but I'm just not sure what quite yet. So what I'm going to look at is I'm going to look for information either in my problem or I'm going to look for information from my table. So just to be straightforward, in my problem right here, my only number is 5. And because of this word total right here, I've established that it's an additive relationship. So technically, I should know that it's x plus 5. Now, what if I wasn't given a word problem? Well, that's easy. I'm always looking for my relationship from x to y. In this case, that's going to be from top to bottom. So from 1 to 6, from 2 to 7, from 3 to 8, 4 to 9, and from 5 to 10. And I have to make sure that it's consistent. So for example, I could get from 1 to 6 by multiplying 6 or by adding 5, but I can't get from 2 to 7 by multiplying 6. I can only get there by adding 5. Same here, adding 5, and adding 5. It's a rule that fits all my ordered pairs. So if I'm going from top to bottom adding 5, my rule is going to be y equals x plus 5. So now that I have my table, my ordered pairs, and my equation, I can take all this and I can turn it into a graph. So first thing I'm going to do is I'm going to label. So I already have my numbers. So I'm going to look at what I can label my x-axis and my y-axis. So my x right here I see is the weight of my items. So I'm going to put weight of items. And on my y, it says total weight. So I like to turn my paper to the side, make it say total weight. And then I can start just applying my ordered pairs. So I have the ordered pair 1, 6. I have 2, 7, 3, 8, 4, 9, 5, 10, and then my bonus point was 0, 5. So what I'm going to do now is I'm going to connect them all together to make a line. So I'm going to grab just like some paper over here. I like my lines to be very straight. And on the end of my lines, I'm always going to put an arrow because my line never stops. It keeps going. So I put an arrow at the top and I put an arrow at the bottom. Now, let's take a look at what my graph looks like. This point right here is called the origin. And it's important for me to know whether or not my graph hits the origin. So right now my graph will not ever pass the origin. It's all the way up here. It's never going to hit down here because it's going to keep going like that forever. So what I'm going to write over here is doesn't hit the origin. Now it's a good habit to figure out whether or not it hits the origin, because if you're looking at a graph, all you need to know to determine if it's additive or multiplicative is if it hits the origin. I know mine does not, and that means it is automatically additive. Automatically, hit your little arrow up here to additive. It does not hit the origin, automatically additive. Let's talk about verbal descriptions. So verbal description, I like to use a general sentence stem. My sentence stem is the following. I like to look at the value of y is, and I let it put a little blank here, the value of x, because when we write an equation, we're writing what y is in the terms of x. So why not put my verbal description like that? So I have the value of y is blank, the value of x. So let's look at my equation so I can fill some stuff in. So the number I'm working with in my equation is 5. So I'm going to put a 5 right there. And this is an additive relationship. And I'm adding, I'm not subtracting. So a word that goes with adding is more than. That's how I can verbally describe. So my sentence will be, the value of y is 5 more than the value of x. And that works. Let's talk about multiplicative. Multiplicative. So, straightforward. Multiplicative is going to be a relationship between two quantities that involves, you guessed it, multiplication. Multiplication. And let's talk about this standard equation here because it's a little bit different than what you might expect. So my standard equation for a multiplicative equation is going to be y equals ax. And I know what you're thinking. Well, there's no multiplication sign there. Shouldn't it say x times a? Well, something we learned a long time ago in my order of operations unit is that if there's two variables or two numbers or two things in general next to each other with absolutely nothing in between, well, that's automatically multiplication. So instead of putting my number in the back end, I'm putting it up here in front of my variable. Let's take a look at this in context of a situation. I'll read this one to you. It says, Oscar sells bracelets for $2 each and donates the money he collects to a charity. What is the relationship between the number of bracelets sold and the total donation? So I have a nice good keyword right here. This word each. This signifies a multiplicative relationship. It's something we've been familiar with for a while now. So if I was just reading that and I didn't already know it was multiplicative, that's something that could tell me, yes, this is going to be multiplication. Then I have my only number here in my problem, which is 2. So I'm thinking that I might be multiplying 2, but let's see. So my X right here is going to be the bracelets, and my Y is going to be my total donation. So if he sells 1 bracelet, he makes $2. He sells 2 bracelets, makes $4. If you want to make $6, you got to sell 3 bracelets. 4 bracelets gives you $8, and 5 bracelets gives you $10. So like I said on the last one for the table, my additive, I'm looking for my relationship from X to Y. In this case, it's from the top to the bottom. So I need a consistent rule that works for all of these going from the top to the bottom. Like I could add 5 plus 5 and get 10, but I can't add 4 plus 5 and get 8. So I'm going to look at another way. Another way I can get from 5 to 10 is times 2. And that works across the board because 4 times 2 is 8, 3 times 2 is 6, 2 times 2 is 4, and 1 times 2 is 2. So I know that I'm going to be multiplying 2. Let's save that information for our equation. Let's just skip to the ordered pairs real quick. So my ordered pairs, my first one right here, I have 1, 2. I have 2, 4, 3, 6, 4, 8, 5, 10. We're going to look at our bonus point. So my bonus point is always thinking, what about 0? So what about 0? If Oscar sells 0 bracelets, is he going to make any money? Absolutely not. So 0 bracelets, that's $0. Let's do our equation. I know it's going to be y equals ax. So I'm going to put my y. I'm going to leave a little space. I'm going to put my x because I don't know what my a is, but I know it has to go right here. So like I said earlier, I'm multiplying by 2 to get from the top to the bottom in this table. So the number that I need to plug in right here is 2. And that's it. I have my equation y equals 2x. And it's important that I write it in that order. I can't write y equals x2. I have to put my coefficient or my number in front of the variable. I have to put that one first. Let's do a graph. So we already had established that the bracelet sold is my x. So along my x-axis, I'm going to put bracelets. And I established that my total donation is my y. So I'm going to turn it to the side and I'm going to write total donation. And then I'm going to graph. So let's see, we have the points 1, 2, 2, 4, 3, 6, 4, 8, 5, 10, and then we have our bonus point 0, 0, which we previously talked about. That is called the origin. So let's connect our dots. I'm going to get a little line going right here. Connect the dots, make it nice and even. And on the end, I'm going to put some arrows because that line is infinite. It goes both ways forever and ever. So on the last time when we were looking at additive, we found it doesn't hit the origin. This time, yeah, it goes directly through the origin. So what I'm going to write is it hits the origin. What? Okay. You're not being that quiet is the thing. Now on the last time, when we said it doesn't hit the origin, we said that means it's automatically additive. Same goes here. If it hits the origin, it means it's automatically multiplicative. All right, and let's finish off with a verbal description. No matter what kind of equation it is, we are always going to use the same sentence stem. The value of y is blank the value of x, because our equations are always going to be y in the terms of x. So this time I'm working with the number 2. So I'm going to plug in a 2 right here. And I'm multiplying 2. So the best way that I can describe that in words is the word times. The value of y is 2 times the value of x. And I actually could have used a different word here. Another word that I know that means 2 times is twice. So I could have said the value of y is twice the value of x, but either one works.